Hello everyone, how are you? Today we are going to launch AWS RDS Aurora database with MySQL flavor. Amazon RDS or Relational Database Services Aurora is a managed relational database service provided by Amazon Web Services. It is designed to offer high performance and availability while reducing the operational overhead typically associated with running the database. Here is why launching an Amazon RDS Aurora database is very important. So the first point is that Amazon RDS or Aurora is a managed database service. What does it mean? This means that AWS takes care of all routine administrative tasks such as database setup, patching, backup, recovery, scaling, everything. Second, Aurora offers high performance with low latency and high throughput. Third, Aurora provides high availability with automatic failovers. Fourth point is that Aurora allows you to automatically and elastically grow your storage capacity as your data grows. So you don't have to manage your storage. Fifth, Amazon RDS Aurora performs continuous backups to Amazon S3 and transparently recovers from physical storage failures. Instance failure typically takes less than 30 seconds. Sixth point is that Amazon Aurora is compatible with MySQL and PostgreSQL, which makes it easier for developers to migrate their existing database to Aurora with minimal changes to their application. Security. Aurora supports encryption at rest and in transit, ensuring that data is secure both while stored and being transferred. And also it is cost efficient. So AWS claims. So in summary, launching an AWS RDS Aurora DB can be important for business that require a high availability, high performance, scalable relational database without overhead of managing infrastructure themselves because it's serverless. It's particularly beneficial for applications that demanding rapid scaling, fault tolerance, and consistent performance. So if you are new to this channel, kindly like, share, subscribe, and comment your thoughts. Let me know what you liked and what you didn't like. I will try to make some recommended video from you guys if you have any. So sit tight and enjoy. So hi, in this part, we will be talking about how to create an Amazon Aurora uh, data RDS database with MySQL compatibility. So before going into how to create that, so we have to know what Amazon Aurora actually is, right? So AWS Aurora is kind of one flavor of RDS database, and it has two compatibilities. One is MySQL and one is PostgreSQL. So AWS Aurora, as AWS claims, it has like highly scalable, high performance, high availability, secure and cost-effective database built on modern serverless architecture. So this is the serverless architecture. So this AWS Aurora has couple of features in it. So one of the main feature of it is it has high performance and scalability. So how does it achieve that? So the high performance and scalability achieve that automatically. So this Aurora automatically scales input output match the needs of your most demanding applications. So also it has the serverless configuration. Also it has kind of 5x throughput over the MySQL and 3x throughput for the PostgreSQL. So also it has this high availability and durability. So this Amazon Aurora actually multi-agent deployment supports multi-agent deployment. This makes Amazon Aurora highly available and durable. This also kind of fault tolerant. This Amazon Aurora is also fault tolerant and self-healing storage. So it has kind of storage is for transparently handling of loss of up to 2 copies of data without affecting the database write availability. Also, it is highly secure, cost effectiveness. So Amazon actually demands that this is highly cost effective solution for your RDS, but it actually depends on application to application. If you think that you are more cost effective on your EC2 on-premise database rather than Aurora, that is up to total the application managers and the use cases. So this is fully managed. That means this AWS Aurora, we don't have to manage this database. The patching, monitoring, everything is done by AWS itself. Also, the most important part that I find it very much important is that it supports now the generative AI. So this actually this Aurora database actually enabled machine learning and generative AI models to work with data stored in Aurora in real time and without moving the data. That is very much important. And also you can store embeddings from ML and AI models such as those from Amazon Bedrock, Amazon SageMaker, which supports the PostgreSQL database. So we can find various topics of it in the AWS documentation, and AWS Aurora is more. I feel like it's effective, and it's high performance and a high available database. Also, AWS Aurora integrates with couple of native AWS services like S3, CloudTrail, Redshift, GuardDuty, Lambda, SageMaker, this machine learning, this CloudWatch, Secrets Manager, and many more. Lambda. So this makes Aurora, yeah, a much versatile database to work with, and it has lots of features available. The next is how what we will do to spin up this Aurora RDS database. So we have, if you see here, we have one VPC. Inside this VPC, we have subnets. So we have three availability zone. One is US East 1A. So basically, we will do everything in US East 1 region. And so in on that particular region, we have one public subnet and two private subnets. So the private subnets is the one where we will spin up the Aurora database. And within this private subnet, we will not have direct access over internet. What we can do, we will spin up one bastion host, that is one EC2 instance in the public subnet, and from that EC2 instance we will jump over to this Aurora database, or we will connect to this Aurora MySQL flavour database, and we will query through the database. So we will do everything in scratch. We will set up the Aurora database in our private subnet, which is more secure. We will set up the user ID and password and everything. We will log in through there from the bastion host, and we will show you everything hands-on in this tutorial. So sit tight and enjoy this video. So welcome back here. In this part, we will do the practical, and we will spin up the Aurora MySQL flavour database through our management console. So what we have done till now is that I have given you an overview of what we will be doing, and I have given the architecture diagram ago. And now what we are doing is we have logged into the management console, and we are ready to spin up our RDS MySQL Aurora instance. So first of all, what we need to do here, if you see the architecture diagram, we need one VPC. We need couple of subnets. Basically one public subnet and two private subnets. So private subnet is the where we will spin up our Aurora database, and the public subnet is where we will spin up our bastion host, and from there we go to our database that is hosted privately. So first of all, let's check our network infrastructure. So to check that, we go inside this VPC console, and inside this VPC, if you are new to this AWS, or if you have spin up on one new account in AWS, you will always get one default VPC, and that default VPC will have couple of subnets, route tables, internet gateway, but no NAT gateway. But in this video, we don't need NAT gateway. So what we need is the VPC. So currently we have one VPC, and we will use the same one. If we go to subnets now, you will be able to see a couple of default subnets that is already there. So we will use that one only. So basically, as I will be using North Virginia region, and US East 1 have 6 availability zones. So that's why 6 subnets has been spin up. So what we can do, we can select either of these 3 subnets as per our architecture diagram. So in US East 1A, we will have our public subnet, and on B and C, we will have our private subnet. So what we can do here, we can see that the availability zone is US East 1B. So this one will be our private subnet. So we can rename this one to private, and 1C should be the private one. This one we will also rename this as private, and 1A will be the public one. So this one is the public, so we will rename this as public. So this is our 3 subnets. One is public subnet and 2 private subnet, but naming them public and private does not make them public and private, right? So we have to do something else. So the public subnet is fine. So if you see here, if you select this public subnet, if you scroll down to the subnet configuration or the details here, you will be able to see that auto assign public IPv4 address is yes. That means this is a public IPv4 address will be associated whenever there is any resource will be launched in this subnet. So that means it will be public. And also what makes this subnet public is that if you go to the route table configuration, you see that this route table has local route within this local subnet, but other than the local route, everything will go to the internet gateway and internet. That means this subnet have internet connectivity. So that is public. Now, if you go to one of the private subnet, that also has the same configuration. Even the details, if you go here, auto assign public IPv4 address, yes, and route table configuration also, it's going to internet. So that means we have to do something here in the private subnet to make it actually private. So what we first have to do? So first, what we have to do, we have to disable this auto assign public IPv4 address. So to do that, you need to select this private subnet, go to action, and go to subnet settings, and here uncheck this one, enable auto assign public IPv4 address. So this will make each and every resources that will be spin up in this subnet do not have a public IP association. Now this is one part. The second part is, but still this subnet have a internet connectivity. So for that, what we need to do, we need to go to route table and create one route table, private route table. So I will give this name is private route, and I will select the VPC is the default VPC, private route, this is fine, and I will create the route table. Now this, whenever I will create this route table, you see that it has only one route associated with it, that is the local route. But if you see the other route table, that is the default route table already had, and if you see the route propagation, the routes, you see here the internet connectivity is there, but for the private route, no internet connectivity. Now what we have to do, we have to associate our private subnet here to the private route table and public subnet to our public route table. So if I go here, if we select the private route table and edit subnet association and select our two private subnets, that's it. Our subnets have been associated to the private route table now. And if we go to public route and go to subnet association, we need to edit the subnet association and we need to select the public subnet and save association. So that will make the public subnet as public and private subnet as private. So now if we go to subnets, if we select the private subnet, the route table, we see that this is the private route table and it has only privately accessible, no internet connectivity. Similarly for other private as well, only locally available, but the public has internet access. So that means our architecture diagram is now from subnet networking perspective, this is complete. So our public subnet has internet connectivity and private subnet have only local route available. So that's fine. Now what we can do, we can do one EC2 instance. So we need our bastion host. So we need to have our bastion host that will be required to jump into the databases, right, privately. So we need to spin up one EC2 instances as a bastion host. So we go to instances and launch an instances. We need, so maybe the name will be bastion host, and we need only one instance for that. We will select Amazon Linux 2 and the instance type is T2 micro is fine. If you want to be in the free tier, please select T2 micro. Key, I don't need the key pair right now because I will connect this instance with the EC2 instance connect, which is very convenient to use. And in the network setting, what we need to do, we need to select the subnet. So the VPC is fine and the default subnet is, I will select the public subnet. So this is the public subnet. So I want this instance to be in my public subnet. So that's how we are going to connect to it. And it will create a security group launch wizard and it will have SSH connectivity SSH connectivity from anywhere. So in the production environment, do not give this from anywhere, only give from your IP. So my IP, this is fine, but as a demo purpose, I am giving anywhere. So this is fine. And everything else I will leave as it is and I will launch the instances. Now this will take some time to launch the instances. So you see here the instance is launching. This is my instance. My instance is launching. Now the concept is that my instance will be here in the public subnet and it has a security group that we have currently created, and the security group gives us access. If we select the networking here, we see the inbound connection. If you select the security, we see that inbound connection on port 22, everything is open. So that means I can log into the bastion host. But after login to the instance, what we need another route, or we need another security group. That security group will be the DB security group. So we need to propagate that security group from our bastion host. So we need to create another security group for our database instance, which will allow traffic from our bastion host. That means we need to allow from this security group any connection or any transaction that is coming from our public subnet resource EC2 instance, that is our bastion host security group. Because whenever any connection will go from this EC2 instance to anywhere, it has to propagate from this security group. It has to go out of the security group connection. So any connection which will be outbound from the security group needs to be inbound in this security group. That's how it will make the connection. So we will create another security group, that is the DB security group, and we will select the inbound connection or inbound transaction or route from our EC2 instance or bastion host security group. So in the EC2 console itself, we will go to security groups and we will create a security group. The name of the security will be DB security group, and we will select the VPC. This is fine, and we will select the inbound rules. So from the inbound rules, what we need is that we need MySQL. So MySQL Aurora. This I will delete. So I will select MySQL. So we need this type of connection, and it will automatically select the port, and from where we need to select the custom range, and the range is from our EC2 security group, that is our launch wizard security group, launch wizard 1. So you want to verify this one. The last digit is FDDE. So if we again go to our EC2 instance, and then security, we see the security group is FDDE, launch wizard 1. So that this is what we have selected, and outbound connection is fine, and we will create the security group. Okay, so we have to give the description, and the description is same as name. This is fine. So we will create the security, and we will use the same security group for our database instance. So this database instance will have connection only from our bastion host. This is what we need. So this makes our database only private. Now our instance has been launched. This is how our instance has been launched. Now the next part is to launch our database. So to launch our database, we need to go to RDS. So you can type in RDS here and open up our RDS. And first of all, we need to create one DB subnet group. So this subnet group is nothing but our grouping of two private subnets that we have created. So we go to subnet groups and create DB subnet groups, and the name is DB subnet group, and the description is same. The VPC is fine, and for availability zone, I will select C and B. Basically, if you see the architecture here, so we have created the subnet group, two private subnet on B and C, not A. A is the US East 1, A is the public subnet. That's why we have selected B and C. This is fine, and the subnets is this one and this one on the subnet that is belongs to US East 1B and one US East 1C. This is fine, and we will create the subnet group. So this subnet group has been created. Now the main part, we will go to database and we will create database. And as soon as you select the create database, you see that the standard create is there, and we will select the Aurora MySQL compatibility. Basically, we will create one Aurora database which has MySQL compatible. Now we don't need to select anything here. We come down and select dev and test. So basically, this is a demo project, so that's why I am creating a development or testing environment. And if you want to create a production environment, you can select this one. But for testing purposes or to follow through this video, you can just select this dev or test. So DB cluster identifier database 1, this is fine. You can leave it as it is, or you can change it as per your need. I'm leaving it as it is. So the master username, then we have to give, I am giving it as admin. And for password, so for password, to be making it very simple, I am just giving the password as PASSWORD password. But for in production, do not give this password as it is, give a complex password with this combination. Now, if you come down here, the cluster storage configuration, this is a new properties here in this Aurora MySQL compatibility. So I will leave it as it is, Aurora standard. I think if I select this production, it will change, but for development and testing, Aurora standard is fine. Now the instance configuration. Instance configuration is memory optimized. I don't need that because this is very much costly. I will select the burstable classes and dbt3 small is fine. This is less costly, and for demo purpose this is fine. Now the availability zone, I don't want to create any Aurora replica right now, so select this one. If you want to create multiple replica in a different availability zone, you can select this option. So what is a replica, what is how it is affected? If you don't know that, please let me know in the comment section. I will explain it. In the connectivity section, I don't need any, don't connect an EC2 compute resource. This is this one I will select, and network type IPv4 is fine. I will select my bastion host to connect this this DB instance. So this is fine for me. And DB subnet group is the one that has been already been selected. DB subnet group publicly accessible. I will select this as no, because no database should have public accessibility. This is very important from security perspective. Now from VPC security group, this is the one that we have created, right? So we will select choose existing, and from the existing one we will select the DB security group, which has the inbound connection from our bastion host. This is fine. And the availability zone, I will select no preference, anything is possible. And apart from that, this will have this additional configuration I am not going into because this has the port. So if you need your database to be run on a different port, you can select this one. I will leave it as it is because I have configured this port in our security group, so this is fine. And DB authentication, the password authentication, so I will authenticate my database with my password. This is fine. Enable. So my monitoring is enabled. This one, for demo purpose you don't need that, but you can select it. There is no harm. And everything else is okay, and I will create the database. As soon as I click on create database, it will take a huge amount of time. So basically, maybe for me, I think it was 5 to 10 minutes it will take. So after 5 to 10 minutes, maybe I will come back, or we will resume this video. Okay, now I see my database is ready and my reader and writer instances are up and running. What we can do is we can go to EC2 console and select this bastion host. So basically what we are going to do now, as my reader and writer instances are both up and running, so we will go ahead in the bastion host, and from there we will go inside this database. So we go here in our bastion host and we select connect, and from EC2 instance connect we are going inside this EC2 instance directly. And upon going there, I'm inside my EC2 instance. So if I now type in MySQL, you see here MySQL command not found. So what we have to do, we have to install MySQL first. So to install that, there is a command. So this is the command where we will install the Linux extras first. So we will hit enter. So as soon as I hit enter, it will ask me a couple of prompt, and then I will select as yes, and it will be installed. And this is complete now. And the next command is to install this MySQL community server. Now we have to install this community release, community RPM from dev MySQL server. You can do it in other way around. What we can do here is that we can install this MySQL release RPM from this dev community, and we have to hit install. So I have already installed this one, so you see here nothing to do. You just have to make this command. Then there is another command where we will be installing the community server as well. So this is the command by which we will use MySQL community server. It's collecting all the packages, and it will ask me for permission. I will give yes, and this is fine. It will ask me again, and I will give yes, and this is fine. So this is actually installing the MySQL community server, and it will take some time. And it's completed. Now we have to enable this MySQL service. So to do that, we have this command sudo systemctl enable MySQLD, and we have another command to start the MySQLD server. So the command is sudo systemctl start MySQLD. This will start the MySQL server or MySQL service, and we can check the status. To check the status is, this is the command, and we can see that MySQL is actively running from in our bastion host. Now the next part is to log in to our RDS, to our login to our Aurora database from our bastion host. So to do that, we have this password authentication. We have selected that our database will be authenticated via password. So we have to give one command by which it will be authenticated via password, and it will be log into our reader and writer instances. So we have two endpoints. If you see here in the RDS segment, we have two endpoints. We will be going to this individual endpoints, reader and writer instances separately. So to do that, we have one command. So first of all, I will copy this writer instance endpoint. I will copy this one, and we go back to our EC2 instance bastion host, and we have this. We have one command. So to do that, we will select as MySQL -h, and then we have this endpoint. So this is our writer instance. So we will first log into our writer instance. And how do we want to log in? We will use this user as admin, and we will use password authentication. So the password is, it will prompt me the password, and it will ask me the password. So the password I will give as PASSWORD. As soon as I give the password, you see that I am inside my MySQL. I have logged into the writer endpoint. Now you can, so to verify, you can select as so databases semicolon, and this will show me all the databases that is launched as a standard version of MySQL Aurora server. We can also check the global variables like Aurora server ID. So to check that, we have this so global variables. So global variables like, then it will be like, so Aurora underscore server underscore ID. So this is how you check that, and this is the instance. So database 1 instance 1, and you can verify this one from here. Database 1 instance 1. This is the writer instance. Now similarly, we can go to the reader instance. So you can create now your own database. You can create your own tables and structure your schema and everything. You can push data into this MySQL Aurora server. This is burstable instance that we have created. It will automatically scale up whenever needed. It will automatically scale down whenever needed. So this is very much important. Now we will exit from this one. And what we can do here, we will again go to the reader instance now. So to go to the reader instance, this is the command is similar. What we can do here, we can just delete the writer endpoint, and instead of the writer endpoint, we give the reader endpoint. The reader endpoint is this one, and we will hit enter. As soon as we hit enter, the password will be same for DB cluster, and we are inside this database. So the same concept, so same command, we will show the database. This is the database. This is a standard database. As soon as we create the database, it will be there, and we can also see the global variables Aurora server ID. This is fine, and this is the server DB1 instance one. You can verify that here in database 1 instance 1. So this is how you create a database instance of RDS or DB instance of Aurora flavored, which is very much important, very much fun to work with, very much also AWS says it's cost effective. You can use that. You can also make a connection from your application to this database easily, and you can use that. So that's it. This is what I wanted to show you. Let me know how do you like this video in the comment section. Please do like, share and subscribe here to my channel. If you are new here, please share it with your friends as well. Please let me know in the comment section in which area you want to learn more I should make video. Then I will be back with another set of exciting videos. So till then, take care. Goodbye.